Here are two similar triangles, and the ratio of their sides is 2:1. This means that the length of each side of the larger triangle is twice the length of each corresponding side of the smaller one. Now, let's see how many of the smaller triangles we can fit into the larger triangle. Do you think we'll be able to completely cover the larger triangle? You will see that we can fit 4 of the smaller triangles into the larger triangle to cover it completely. This means that the area of the larger triangle is 4 times the area of the smaller triangle. This tells us that when the sides of one triangle are twice the length of another, the area of the larger triangle is 4 times the area of the smaller triangle. To generalize, we can say that the ratio of the area of two similar triangles is the square of the ratio of their corresponding sides. This is known as the area of similar triangles theorem. Now, let's try and prove this theorem geometrically by taking two triangles, ABC and PQR, which are similar. We need to prove that the area of triangle ABC by the area of triangle PQR is the square of the ratio of their corresponding sides. To calculate the area of each triangle, let's draw segment AD perpendicular to BC and segment PS perpendicular to QR. Now, let's prove the theorem in 4 steps. Here's the first step. We know that the area of a triangle is half the product of its base and height. So, the area of triangle ABC is equal to half BC into AD. And the area of triangle PQR is equal to half QR into PS. Working out the ratio of the area of the two triangles, we arrive at this equation. Let's call this equation 1. Now, let's move to step 2. As triangle ABC and triangle PQR are similar, we can say that angle B is equal to angle Q. Also, angle ADB is equal to angle PSQ as they are right angles. When two angles of one triangle are equal to two angles of another, we can say that the two triangles are similar by the AA similarity criterion. So, triangle ABD is similar to triangle PQS. Now, we can say that AD upon PS is equal to the ratio of AB upon PQ, as they are corresponding sides of similar triangles. Let's call this equation 2 and move on to step 3. As triangle ABC is similar to triangle PQR, we know that the ratios of the corresponding sides of the two triangles are equal. Let's call this equation 3. Now, the final step. Here, let's go back to equation 1 and replace BC upon QR with AB upon PQ. From equation 2, AD upon PS is equal to AB upon PQ. Let's substitute this in the equation and simplify it. We can now see that the ratio of the areas of the triangles is equal to the ratio of the squares of the sides AB and PQ. Similarly, by using the other ratios from equation 3, we get this statement. So, we have just proved the area of similar triangles theorem.